Okay, good evening. I'm Donna Schneider, president of the Prince George's County Historical Society. Welcome to our June 30th, 2025 History Chat. What is preservation? It's with Alfonso Narvaez. He's the principal architectural conservator, and John Peter Thompson, chair of the Prince George's County Historic Preservation Commission, and they will chat about historic preservation. We would appreciate if everyone would mute their microphones. We will be recording tonight's chat, and it can be found on the Society's YouTube channel, which can be reached through our website, www.pghistory.org. As you may know, the Society does not receive any funding other than through member and sponsorships and donations. If you like our history chats, think about becoming a member if you aren't already, or making a donation. We'd like to keep these history chats free for all, and one way we can do that is by the memberships and donations. So thank you. Just a little bit about our guest tonight. Mr. Narvaez is a founding principal at Aon Preservation Services, LLC, which was established in 2010. He's a senior architectural conservator with over 40 years of experience in the technical preservation of historic buildings and monuments nationwide. Alfonso has worked for John Milner Associates, Inc., a national consulting firm specializing in architecture, conservation, landscape architecture, archaeology, and planning for historic properties and sites for over 20 years before he left to establish an independent practice. Prior to JMA, he worked as a historical architect for the National Park Service, North Atlantic Historic Preservation Center. For the past 25 years, Alfonso has taught seminars throughout the U.S. through the National Preservation Institute and is currently on the faculty of the University of Maryland School of Architecture, Planning, and Preservation. His clients have included the Architect of the Capitol, GSA, the National Park Service, the Smithsonian Institution, the U.S. Naval Academy, as well as private entities and institutional clients. In addition to his professional roles, Mr. Narvaez is currently the vice chair of ATHA's Managing Board, which is the Anacostia Trails Heritage Area, where he has served for nearly 15 years. He has also served as chair of the Prince George's County Historical and Cultural Trust and the Potomac River Heritage Tourism Alliance. So welcome, Alfonso, and John Peter, it's now all yours.
Well, thank you very much, Donna, and thank you, Alfonso, for taking time to talk with me and talk with our society listeners. I thought that this would be a great opportunity for people to understand what a preservationist is, and I couldn't think of anybody better than you to do this. But before I start, you and I talked just briefly. I think that I have known you for over 20 years as I came on board as a historic preservation commissioner. When I started, unlike you, I had no idea what historic preservation is, or why. You, on the other hand, were already immersed in this. And so I think this is going to be a great conference to learn a lot. So I'm going to turn it over to you. And sort of my first question, what is it that you do?
Okay. Well, thank you, everybody, and good evening. So I'm an architectural conservator, which in the larger ecosystem of preservationists means that I like to think of myself at the pointy end of the stick of preservation, which is to say that I'm the person doing sort of hands-on actual preservation in the field with either contractors or dealing with the stuff, if you will. But I also wear lots of hats. So I'm partly architecturally oriented. I'm an historian to a degree. I am a contractor to a degree, a scientist to a degree. And so all these things blend together to formulate the ground on which I walk. So as a conservator, I mostly am focused on how things were built, how they change, and how they evolve over time, and then how I can influence that and slow down the rate of change, or even restore or reconstruct. But usually I'm just trying to stabilize and protect what we've got. I don't know if that answers the question, but
no, that does answer. I mean, that's what preservation is about. We're trying to preserve a structure, a thing that is important to us at this time. What determines importance, I guess, is sort of in my domain to a little bit. But given that, to slow down, to preserve, to stabilize a structure, a thing, a place. And you mentioned everything from a scientist to a historian. You really have to be knowledgeable in a whole range of things. And I'm hoping that perhaps you can give us some specific examples of.
I will endeavor to do so. I tend to view most of my projects as sort of a crime scene investigation, because I'm confronted with a project that's in the middle of its lifespan, hopefully. Sometimes near the end, sometimes, a little earlier, but with an historic building, you're always starting in the middle, which is to say that there's always a long history of stuff that's happened before you even showed up on the site. And it's your job to finesse that out of the documentary record, out of the physical fabric of the building, out of the evidence left behind by previous maintenance efforts and restoration efforts. You have to really sort of pull together lots of different disparate pieces of information to figure out, what am I looking at? And then what is it that needs to happen in order to preserve what we have and not make things worse? With that, I put together a PowerPoint. It's probably way too many slides, but I think it'll give you a good sense of what I do. So give me a second to pull that up.
This is exactly what I was hoping for. Examples of what you do.
Okay. Can you see that? Oh, wait, no, I probably have to, I haven't done the thing. Where's the thing?
Yeah, you need to share.
Yep, that's the thing.
That's the thing.
Share screen, boop.
This is when I used to have a radio show, what the station told me I could never do, dead air time.
Right.
So, at least I can.
Okay.
Yes.
There we go.
All right.
So I threw up the title of your little chat. So what is it that I do? So one of the areas that we get involved in is what I like to call pre-design investigations. So that's before we've made any decisions and decided to go off in a direction, we get physical information and data about the materials and the pathology of those materials. So that might include doing mortar analysis. So we'll take samples, we'll dissolve them in acid, we'll break out the sands. We'll determine if we can guess or determine what the binder was, whether it's lime or cement or natural cements or what have you. We try to get as much information out of the mortar as we can possibly squeeze out. We might go into more advanced analysis, which I wouldn't do in-house. I'll use a third party for that. Might include petrographic analysis, which also helps me understand what are the minerals and other constituents in the mortar.
Alfonso, I promised that I wasn't going to interrupt you. Why is it important to know the constituent parts of mortar, for example?
So one of the fundamental things that we're looking for is, how do we match the existing mortar, both in appearance, but also in its physical properties? So we want to make sure that the mortar, which is intended to be sacrificial element, is softer and weaker than the masonry that it's holding together. It's not important for the mortar to have enormous strength. It's important for the mortar to do the job of holding the masonry units, whether they be brick or stone or whatever, together, and to prevent moisture from penetrating in the joints between those blocks. But it's the masonry that's doing the work. The mortar is really sort of there to tie it all together. And over time, as we make lots of incremental, repairs, we end up usually with a patchwork of different mortars from different generations. And so part of what we try to do is to find what's the original mortar, and can I afford to bring that back and make a consistent, uniform appearance. But the bottom line is, it still has to work, right? It still has to keep the water out and has to keep the stones and the bricks in position. So
what happens, Alfonso, if you take a 19th or 18th century mortar and you decide to marry it to Portland cement from your local hardware store.
So what would happen would be that the let's say your typical historic brick has a compressive strength of, let's say it's 1,000 psi. Wouldn't be much more than that with an historic brick. Later, more modern bricks might be harder, but that's sort of in the range. If I put together a Portland cement mortar from Home Depot, it could have easily a 5,000 psi strength. So now this mortar is much, much stronger than the brick, so that if anything is ever going to move or break or cause any issues, it's going to be the brick, the historic brick that I'm trying to preserve, that will fail, not the mortar. And I've seen many walls where the mortar joints stick out proud from the brick, and the brick has eroded back from the face of the building and lost its fire skin, and now is exposing sort of the orange stuff on the inside. The other thing that the Portland cement will do will be to introduce more salts into the masonry. And so you'll start to see efflorescence, which is salt crystallization on the surface. And that will start to break down the brick or the masonry as well. So it just causes a lot of trouble. Best not to do it. Best to keep the mortar weaker and softer, and ideally with the same physical properties as the historic mortar, which has never been touched, right? That's in the middle of the wall. We want it all to behave the way it always meant to behave, and uniformly, rather than having different pieces behaving differently or having different levels of vapor transmission. So we're trying to go for uniform appearance and performance over the long term.
All right, thank you for letting me. This is a big problem for the Prince George's Historic Preservation Commission, as homeowners try to do it themselves and then wonder why the commission gets a little bent out of shape.
You guys can get salty, I know.
Yeah, so let's, I'm sorry. So back to our scheduled program of slides.
Okay. All right. Donna, if I run over, it's his fault.
Yes.
So another thing we might get involved in is paint analysis. So often a historic district commission will say that they want a building to be painted to its original color, and the only way we will know that is if we take samples from the surface and look at them under the microscope and try and figure out what the original color was. And we have a whole range of possible tools that we can go to. If it gets too sophisticated, I'm going to bring in a specialist, and they're going to do it, because, to be honest, paint analysis is exceedingly boring, almost as boring as watching paint dry. So, but it's a useful tool in our toolkit, and you'll see an example of that in action later on. We might get involved in petrographic analysis. So that's where we're taking thin sections of stone or mortar and then evaluating them under the microscope. And that allows me to understand what kinds of issues I might have with the stone, what kind of the green arrows are pointing to fossils. The red arrow is pointing to what's called a stylobate in limestone, which is an area of weakness in the stone. The orange things are areas of epoxy resin repair from way back when. So those kinds of things are all things that I'm interested in, is how porous and how structurally sound the mortar is, or the stone is, and what's happened to it in the past. We might get involved in architectural investigation, and that might be dating nails and screws, or tool marks in this case, looking at adze marks or pit saw traces or circular saw traces. And I'm looking for uniformity, right? These are fingerprints as far as I'm concerned. So if everything is all of the same, if it all looks like the top right-hand side, then I can reasonably say that everything was cut and dressed at the same time. But if I have lots of different treatments to the wood, then I know that those are different things. And so I start to map those out to try and understand the evolution of the building to see what's what. When we start getting into treatment, I will often take samples of all the different materials that I might want to try and do test panels and say, okay, I'm going to use product X for a certain amount of time at a certain concentration, and then I'm going to rinse it off. So I'm going to follow the manufacturer's instructions as close as I can, and then say, okay, how well will it do if I cut it in half and make it much more dilute? Do I get the same amount of cleaning? Because what I want to do is do the most gentle approach that I can that still accomplishes my objective without over cleaning. So that's something that we often very do a lot is test various procedures and materials in place so that we can write our specification with the most information possible. And sometimes things that we think are going to work don't work, and things that we don't expect to work great. Sometimes just water works great. So, we want to be the least toxic, both for the environment, but also for the building fabric. We also might test different kinds of products that this is a paint stripper that's dissolving the bond between the paint and the wall. So that's allowing it to sort of release, but you notice it's not dissolving the actual paint. So it's not like a methylene chloride stripper where it's attacking the paint, it's attacking the bond between the paint and the surface. So those things are in our toolkit, and we evaluate lots of those things. The other thing we'll do often, we often say that moisture is public enemy number one. So we will get involved in moisture investigation, which might involve using a variety of tools. And on the right-hand side, we're looking at the ground around this particular courthouse to look for any kind of anomalies or water sources that might be penetrating the interior. We might use, on the right-hand side, that's a moisture meter, electronic moisture meter that we're running up and down to figure out where is the changeover from wet to dry. And in this case, it's about 14 feet up the wall, which is exceedingly unusual. And we also look for visual clues, such as on the left-hand image, where you see areas where the moisture has clearly gone up to the interior, and they've made an ill-advised attempt to put on an elastomeric paint, a plasticky paint, to try and keep the water in the wall. And that's failing, of course. The plaster is still dissolving and breaking down, bubbling up, and causing this sort of skin cancery look to the interior of the building. So we try to figure out why. What's the underlying issue, and why is it misbehaving? And obviously, since this is an extreme example, something has changed, right? This is not the way a building normally responds. And what has changed is that somewhere along the line, they put a Portland cement plaster on the outside and a Portland cement plaster on the inside. And so that's trapped all the water inside this 1840 brickwork, and it has nowhere to go. And it's still looking for a place to evaporate. So it's just going to keep climbing up until it finds a place where it can get out. And so that's what we're trying to figure out, the whys. Here's another way of looking at moisture. Again, visual clues on the left-hand side. On the right-hand side, we're using thermal imaging, which shows me where the moisture is in the wall as a function of temperature. And the reason it shows me that is that a wet wall is denser than a dry wall. And so it will gain or release heat energy faster. The dry wall will release it faster. And so I'll start to see a difference between the wet and the dry areas. And it just gives me more information to try and understand what's going on and why. Now, other things that I might do, this is an historic fort in Louisiana, Fort Pike. We were called in because, as you can see in the bottom left there, the wall is shifting and shattering, and we had made a presentation to the Department of Natural Resources in Louisiana and said, we're going to be in the area. Would you like us to? And we came to an understanding. We did our investigation. This is laser scanning that we've done inside the fort casemates. So you can see the outside of one of the corners, and then the inside are these casemates. Each color represents a different laser scan. That's why they look different. But you can also see in the right-hand side that the vault is sway backed at top. That means it's flattening out and settling, and is eventually going to crack and fail. Now, 3/4 of the way through our investigation, Hurricane Katrina came through and caused all kinds of damage. And so then we got involved in evaluating what the change was from pre-Katrina to post-Katrina in an effort to try and help Fort Pike navigate FEMA and trying to get money to do some of the reconstruction, but also look at the things that happened to the building over time, and how we could solve that, how we could help save the site and make it once again be open to the public. This is in Plaquemine Parish. This is Fort Jackson, which also got hit by Hurricane Katrina. I looked at about 4 or 5 historic forts in Louisiana. But this is after the waters went over the levee at Fort Jackson. The water stayed pretty much at the top, and it went down to about the halfway level. and then stayed there for 6 weeks. So we ended up with this sort of bathtub ring of salt around the entire fort. And then that salt then started to contribute to damage to the masonry and loss of mortar. And so again, trying to encourage FEMA to do the right thing, but turns out that FEMA has certain four-letter words that it doesn't like to deal with, one of which is silt, salt, tree, or anything else they can come up with a four-letter word they won't fund. So we spent years trying to help Fort Jackson recover some of the funds that they needed to recover in order to come back from Hurricane Katrina damage. Here's my business partner. This is Lane Burrett. Here we're looking at some of the mortar that's washed out of the wall. We're in a boat in the moat going around the outside of the fort and looking at the surface of the masonry, trying to figure out what. And then the salt also affected everything that was made of metal inside the building. So we did a comprehensive investigation of every metal feature to look for active chloride corrosion cells that were going to accelerate the loss. A lot of this stuff had some surface rust, but it was stable. And so what happened with Katrina is that it destabilized everything and caused it to start to rust much more aggressively and result in loss of fabric. Rust, though, also a four-letter word. So the other area that we get involved in is architectural support. So this is where we might be working with or for an architecture firm, and we will do investigations, often test panels and things like that lead to then a full-blown project. And sometimes we would manage that project exclusively within the conservation group, or sometimes we would work with architects and the architectural team to execute the larger project, depending on what the scope was. This is the Corcoran Museum of Art. We did a test panel to clean the exterior. That led to a report, which led to helping them get a Save America's Treasures grant for restoration of the masonry exterior. This is in the middle of that project. And here we're using just water mist to clean the marble. We're not using any chemicals. You can see at the very top there where the lift platform is. Above that, there's a that's a little section of PVC pipe with lots of little nozzles on it. That's just putting a little bit of mist on the surface, and this is allowed to run down. We run it overnight, and so on the right-hand side, you can see how clean it got, and on the left, it hasn't been cleaned yet. So that's a case where just water is good enough. And then, of course, we have other repairs to do. So the tip of this Centurion's hat was damaged, so that had to be repaired, and so on. On the inside, we had at that time an active museum, and so we had to clean the interior stonework, which is limestone, without introducing a lot of water. So here we're using a latex carrier, excuse me, to carry the cleaning solution, hold it on the surface, and then it peels off with that material. That again required lots of testing to figure out what was the right kind, which brand to use, and then a contractor was hired to actually do the work. And then this is the finished product. After the masonry was restored, we then did a huge roof repair project as well. That was done by the architecture side, as opposed to the masonry restoration, which was done by the conservation group. Over time, we've seen larger independent architectural conservation firms emerge. So that's where it's now separate from the architect instead of working with an architect or for an architect. And there we see that these firms are all over the place in terms of size. Some of them are very small. Some of them are much, much larger operations. But in all cases, they're basically doing evaluation and project development internally. So this is a project, this is at Union Station, where we were hired to evaluate the rostral columns, which are these guys up front on the right and left-hand sides. These were the original gateway for Union Station. So if you arrived by ship in Baltimore, you took a train from Baltimore to Union Station, and then a limousine picked you up at Union Station and drove you to the Capitol for your meeting with the heads of state and whatnot. So this was the main primary entrance for VIPs. And so these rostral columns were were very important and very significant. But when we got to them, they were in a sad state, um, fairly corroded. We were worried about the fasteners; things had shifted. Um, uh, we have these original light fixture sconces. These were originally carbon arc lamps, so that meant that it had a stick of carbon and it made a little electric arc to make the light. So this is right at the dawn of electrification. Uh, that, of course, didn't win the game, and we went to regular incandescent light that we know and love now. But carbon arc was the LED light of its day. Um, that had all failed, of course, and so our job was to understand it, map everything out. And so this is where we've laser scanned and created a computer model of just that little section so that we can then create drawings of the whole rostral columns and then map out all the different issues that we were finding. That allowed us then to put together a set of construction documents, which allowed then a contractor to bid on it. And so here they are disassembling the rostral columns and then taking them to Alabama, where they were sandblasted, treated, restored, and then brought back and reinstalled. And so here's the finished product with all new lighting, all new globes, all new paint. The masonry's all been restored. And so this is a project where we would have managed the whole evaluation and treatment process and then quality control. We flew down to Alabama a couple times to make sure they were doing what we expected or that they hadn't discovered anything unusual and that kind of thing. More recently, when we started Eon, we wanted to focus on the construction trades and the contractor. And that's because that's where preservation, we could have all the beautiful plans and notions and ideas at the front end, but it can all fall to pieces when the contractor gets involved. So we tried very hard to say, all right, how do I support the contractor in their endeavors so that they can navigate between the architect and the contractor and the owner? I call that little area between the architect and the contractor, that's the Bermuda Triangle, and that's where all projects die, is in that little triangle, right? That's where change orders come. That's where risk is. That's where there's so many unknowns. So we try to own that triangle as much as possible. We call it bridging the gap. That's the Bermuda Triangle. And what that triangle really is representing is risk, right? It's the risk of unforeseen conditions, hidden liabilities, cost overruns, schedule and cost issues, and other hazards. So the contractor is either going to, increase his price tremendously to cover that risk, or the architect is going to have to do a lot of stuff up front in order to understand it. But at the end of the day, the contractor can only bid what the architect says is the scope, and the owner is only going to pay for that. And so that becomes this area where there's potential for risk. So what we ended up doing was doing a lot of projects where we were being brought in by the contractor, both to help them understand the project, but also to navigate. And because we speak owner and we speak architect and we speak contractor, we often serve that role of translating what's possible, and also translating what the construction documents actually say versus what the contractor is actually supposed to do. So we end up oftentimes we've been on occasion hired by both sides, which is a very unusual situation to be put into. For that reason, I always tell everybody that hires us that for all intents and purposes, we consider the building to be my client, as opposed to you, the contractor, or you, the owner. Everybody here is just a temporary blip in the lifetime of this building. So we're going to try and do what's best for the building. In this case, this is the Miami Freedom Tower. This is owned by Miami-Dade College. It was built as the Miami News Building back in 1928. And the contractor was given a set of construction documents that basically had a big cloud around the tower. And the instruction that the contractor was to hire a conservator to survey the complete outside once access was available, and to determine the scope and to do that scope within the time and budget allotted, which of course is that's called kicking the can down the road. So contractor did a search. We came to an understanding. We flew down to Miami and then did a very sort of comprehensive but rapid investigation of the building envelope via swing stage, via fixed scaffolding, via man lift, and via crane bucket. So you can't be afraid of heights. Another requirement. When we got the drawings, they were not complete, and they were very, let's just say they were thin. And we said, well, where are the original drawings? And they said, well, we don't really have any, and da da da. And so the first thing we did was to do some research and discover that the original architects, Schultz and Weaver, based out of New York City. I went up to Avery Library. They didn't have anything. So I did another search and found that the original drawings for their building was at the Wilsonian Institute in Miami, about 4 blocks from the building. So we went back down to Miami. We made an arrangement with the Wilsonian, and we found these drawings. And these drawings are, it's hard to get a sense of scale, but they're about 4 feet wide and 5 feet tall on 2 sheets. And it maps out every piece of ornament on the facade of the building and its attachments. So for me, this is gold, right? This is my roadmap for all of the different issues that I am going to find on this building. And then we have to start surveying. So, on the left, you see the column capital, and on the right, you see the column capital as it's been, this is actually during restoration. We found that a certain percentage of the capitals had already been replaced with fiberglass, and the fiberglass was falling. Given that this is in a hurricane zone, we really didn't want to have failing masonry fly off the building, or let alone failed fiberglass. And so we determined that new cast stone was needed, and it had to be anchored to allow for hurricane resistance. So those are the new cast stone elements going in. We also help them, train them in techniques that are not common in the Miami trade, in the contracting community. So here we're using what's called a Syntec Hark anchor, and so we brought down the manufacturer to do a training for the contractor to show them how to use this type of very specialized anchor to tie the wall together. I won't go into a lot of detail on that, but that's the kind of thing we might get involved in. And then here's my partner. We're using a packometer. We surveyed every inch of the surface. On the right-hand side, you can see me on a swing stage. We could not, for the life of us, get the structural engineer to come out on the swing stage with us. So we also had to do a lot of relaying of issues through the window to the structural engineer, even though that wasn't really our job. But again, we're in the business of translation. And then here's some of the detailed areas. We ended up mapping out just a tremendous amount of work on this particular building. But that was one of the ways and then doing quality control, right, to make sure things were being done properly and staying on top of all the various issues. And so we flew down once a week to assist the contractor. And for all intents and purposes, the architects and the building owner and the contractor, everybody was happy with that arrangement. This was another project we were involved in. This is the U.S. Capitol Dome renovation. That was a few years ago. Here, our mission, our role was we wore several different hats in this project. One was to communicate to all of the subcontractors the importance of this site and of historic preservation and the limitations that they might encounter in doing their work, i.e. that they could not introduce moisture or the outside hair into the interior. We have this incredible array of artwork on the inside, from the apotheosis at the very top to the frieze at the midway point, to sculptures down at the ground level. And so part of that was to communicate to the contractors what the dealio was. Second was to monitor the building environment during the course of the construction project. And so here we have, on the left, you see that's a data logger array. And then there are a constellation of maybe a dozen or so sensors. You see one here is on a flagpole that's near the top of the big paintings in the rotunda. The one on the middle is up near the apotheosis. That's also on a little flagpole. That's to get the sensor as close to the painted surface as possible. And then we monitor that data during the course of the project, and in part to help protect the contractor, because one of the things that we found, because we did the monitoring before construction and then continuing on, was that the building didn't really have a controlled environment before, so the contractor could hardly be blamed for not having a controlled environment during the project. So that helped to protect the contractor, but also helped to illustrate some of the other issues that were involved in the project. Now, we also we cleaned the whole interior stonework because they didn't trust any normal contractor to touch all the sculptural surfaces. So we spent a lot of time cleaning and dusting historic stonework. Um, we also got involved in historic glass. So up at the very top are these cast glass windows. These are about 3/4 of an inch thick cast glass that were made in England, shipped over, imported by a hardware company in New York City, owned by Theodore Roosevelt's father, shipped down and then installed into the exterior of the cupola. These are the cupola level windows. Over time, though, these have developed all kinds of cracks, and you can see here's some of these cracks. On the bottom right, you see the drawing that we were presented with when we bid on the project. Every drawing was mapped out in terms of its length. And so we scoped that out, and then we did our own survey and determined that the cracks were continuing to grow. So we communicated with the architect of the Capitol that these things were happening. These cracks, in fact, were for all intents and purposes alive, is how we would characterize it. And then we brought in senior research scientists from Corning Glass to talk to them about the nature of glass fracturing, the nature of their scoped out repair, which was to do to sort of wick through a very thin epoxy treatment like you might use for stained glass. So the guy that designed and developed that treatment was part on our team, and he said, no, you can't use that here. That's not what this is for. The glass fracturing guy said, no, the glass is going to continue to fracture. It's not stoppable. This isn't going to work. We spent 1.5 years arguing with the architect of the Capitol about what the proper treatment was, because they kept saying it was irreplaceable. It couldn't be, we had to save it no matter what. And we tried to explain, but it's 350 or 250 pounds for each pane of glass, and it's over the stairs that you bring tourists up. So ultimately we prevailed because we're stubborn that way. And so we took down the broken glass. And then this is me taking down the broken glass. And then we worked with a company in Oregon to cast new sheets of glass. And they developed, they do all kinds of fancy high-end glass, but they created a custom steel platen, which is the table that it's coming out on. And that was preheated to 500 degrees. And then the molten glass, was heated in a big kiln and chemically made to be as close to the original glass as possible. And they would take giant ladles, and then, of course, carefully, because it's 2,000 degrees, bring that ladle of glass over as fast as possible, pour it into this machine, which is like a big pasta roller. And then where that 2,000-degree glass hit the 500-degree temperature, it developed a series of chill marks. And you can just see those in the glass surface. And those are very similar to the chill marks that we had in the historic glass. But we made the glass half as thick so that we could take 2 pieces of this glass and laminate them together and create laminated glass that was as close as possible to the visual appearance of the historic glass, but is now essentially safety glass. And so that was installed over the stairway that the tourists run. They waited too long to do the project, of course, so we only installed 7 or 8 pieces of glass, and they have another 10 pieces of glass in storage waiting to be installed at some point in the future when they decide to re-scaffold the Capitol Dome. Here's another project. This is Bank of Alexandria, one of the earliest banks in the United States, 1807. So Alexander Hamilton is still stomping around, singing his raps about the nature of banking in America. At this point during the Civil War, it became a hotel before Civil War, and then a hospital during the Civil War. Eventually, the hotel portion got torn down and expose the Carlisle House, which if you've been in Old Town Alexandria, you know the Carlisle House is across from City Hall. The Bank of Alexandria building still stands. We were brought in to do investigation about some of the historic elements. Here we're looking at the Aquia sandstone cornice up at the top. Aquia has the unfortunate property that it dissolves in water, so hence typically it's coated, painted white to protect it with whitewash. This is the picture here is the only intact section of cornice that exists on the building. Everything else has dissolved significantly away. So one of the things we did was to work with a partner company to laser scan the that intact section. We laser scanned the whole cornice actually. Excuse me. And that then allowed us to create a computer model so you can see the intact section versus the melted away sections. That computer model was then used to create new stone models that then were allowed stone 3D models for each and every piece, which then allowed us to work with a stone cutting company in Indiana, I believe in Indiana, Ohio, to make new stone elements. And so on the right here, you see restored, reconstructed, fabricated new. This is forget the name of the stone. Anyway, it's this is new limestone that has the same color but doesn't have the unfortunate property of dissolving in water. And so that whole cornice section was replaced. We also got involved in evaluating the original banking hall. So there we've taken away all the modern construction to expose as many of the original features as possible, and then worked with the whole team of historic architects and conservators and specialists in evaluating all of the physical evidence of how that banking hall appeared historically, including evaluating each of the mantelpieces and carefully removing the paint to expose areas where we were missing compo ornament or where we had different colors, that kind of thing. So that's another type of project that we might get involved in. And then finally, we're involved in what we call technical preservation services, which is, for all intents and purposes, design build work on projects that means that we can be a full service firm, starting from the first investigation all the way through implementation. So here we were contacted about this is a sculpture on the White House grounds of William Tecumseh Sherman. In the course of doing the work, a contractor said the surface has turned yellow. We don't know what to do. Just on the phone, I said, you probably have a coating on the surface. They said, no. They say there's no coating. I said, yes, there's a coating. So we went out there and then helped to remove the coating using a microabrasive technique. This is using the Joss Rotec system, which uses microfine crushed glass media, which is like talcum powder when you feel it. And it's very low pressure. This is 25 psi, and that allows the glass is stronger than the coating but weaker than the stone. So I remove the coating, and you can see the before and after between the two sections there. And so that so we basically went over the whole thing with that system, cleaned the monument, protecting all the bronze elements, doing some other repairs, and here's the end product. A lot less yellow. We used a similar technique to restore the bronze doors of the U.S. Naval Academy Chapel, this using a different media. So it's the same system, but now using crushed garnet, excuse me, to remove a painted on coating and lacquer that had been painted on to simulate patina, but was a failed coating. It was falling apart. So we had to remove it 100% and then repatinate the surface and then re-wax the surface. So this is, on the right is the patination chemical applied with heat, and on the left is same thing, heat, but also now wax that then will harden into a very hard, dense wax coating that will protect the bronze. Here's another monument. This is also at the Naval Academy. This was a project that was done by a class gift. So here we had to deal with 4 different elements. We have an 1812 wooden figurehead that's been encased in fiberglass that's on top. We have a 1920s concrete base. We have a 1920s bronze plaques, and we have 1797 era cannon that are actually merchant cannon, not cannon from the HMS Macedonian, but they were the right size, so that's what they used, that have active corrosion going on. So we have all these different disparate elements. So our mission was to take it all apart, restore all the different elements, put it all back together again. That involved, first of all, historic research on the figurehead. So on the left, you see it in its earliest phase when it's still fairly intact in the 19th century. The middle is the 1920s when it was first installed as a monument. And on the right, you see sort of a later 1940s or 50s view of the figurehead encased in lead sheet that has caused the wood to rot. And so now the figurehead, his head's getting cocked, his sagging. There's all kinds of things happening because of the lead sheet, both because of the weight, but also because it's trapping moisture. So we worked with our laser scanning company here to capture all the available information, both from historic images, but also from the physical piece that we had, restored as much detail as we could. And then the middle image shows it being carved, machine carved with a CNC machine in new mahogany, and then painted. And then the original was taken down and put in the museum for protection. The Macedonian has the unfortunate situation that every year the midshipmen decide that they need to paint it green for St. Patrick's Day or whatever is the appropriate color for whatever holiday is going on. And so it gets a lot of abuse. So having the original out there wasn't really viable. Then we took the cannons back to our shop. They weigh about 1,500 pounds each, so we had to have a special lifting rig. And then they were put into a bath, which allowed me to do a chemical chloride extraction from the metal. This took about 3 months of being in a bath with, and we had to monitor the water and change out the water and the chemicals to encourage the chloride cells to be evaluated. You can see the outlines of the cannons and the bubbles on the surface. Here we are doing some other treatment. These are for different cannons, not the same cannons, but and then everything gets put back together again. So we restored all the concrete, restored the bronze plaques, recreated the figurehead, and restored the cannons and put it all back together again. And of course, it's about ready for work again now. So, 18th century house. This is the Lynnhaven House in Virginia Beach. Here we're looking at plaster failure. This building was restored in the 1970s. It's kind of partial reconstruction. They had most of it intact. The masonry was mostly intact. Windows were not historic. And so those are 1970s era replicas. The dormers had been modified. So these are replica dormers, roof, that kind of thing. In the course of doing that investigation, we determined that the kitchen lintel seen here, by the way, again, Portland cement plaster causing all kinds of mischief. So we want to take Portland cement out of our lexicon. Just don't buy it. Don't use it. Just keep away. But in this case, we had extensive insect damage of the lintel. So you can see on the back here, you can see visually see the damage, which is unusual. And you could actually stick your hand into the back of the lintel and have minimal resistance for most of your handling. That's very bad. So we worked with our engineers and our team to come up with a scheme for how we were going to treat it. So here we brought in a custom-made portable rig to carry the load so we could take out the lintel. The lintel itself has been wrapped in rice paper and a very weak adhesive. And then that allowed us to pull out the lintel. The lintel, of course, very badly damaged, but we wanted to retain the original appearance. So took it back to the lab, not my lab, somebody else's lab. We cut off the outer 3 inches along the full length and then treated the backside with a resinous material to stabilize the wood. Carved a whole new lintel that was 3 inches shallower, of course, and then attached this face to the new lintel. And so there's the composite lintel showing the historic face on a new wood backside, and that got installed. back in place. And so here's the restored lintel put back in position, but with all new wood doing the actual work behind. Of course, we've taken down all the plaster and uncovered all kinds of sins. That's a future project, was to restore the masonry. But this is another kind of project. This is the reptile house at the National Zoo. Here, we did a project with an architect to analyze the portico. The portico was showing severe signs of distress in the form of spiral cracks going up near the top of the column capitals and up into the archway and around the pterodactyl. And a spiral crack is very dangerous because it means that we have eccentric loading, right? It's basically trying to wishbone. It's trying to bend apart, which ultimately means that the arch will collapse. So we said, you know what? This is too dangerous. We can't fix it. It's too fragile, too thin. There's not enough meat here. We have to take the weight off. And so we encouraged the Smithsonian to do that. Under a separate contract, they hired our firm and our team to dismantle it. So here we are. We've taken off the roof. We've pulled out some of the masonry that was the weight of that. You can see some of the reinforcement on the top here. Everything was laser scanned, of course, in order to map it all out. Here you can see the reinforcement going across and down behind the pterodactyl. And it's this reinforcement, which is A, too thin, and B, doesn't have enough lateral resistance that's causing our problem. You can see the crack, part of the crack down here on the right. And so the whole thing was then carefully dismantled. You can see them lowering down a pterodactyl on the left. That's the laser scan of the pterodactyl in the middle. That was our insurance in case something got damaged or fell apart. And then everything was carefully crated and put into storage at the Smithsonian's boneyard, where they keep all their stuff. Eventually, hopefully, we'll get to put it all back together again on a different kind of support, and so that it can be A, way less, but also B, be more securely attached and not put so much stress on the columns.
So Alfonso, unless this is your last one, I'm going to have to stop you.
Okay, all right. That's fun. What are we doing here? Oh yeah, sure. So this is the Mel Fish Museum in Key West. We were confronted with a vertical cracking on the corners. They had an HSR. The HSR referenced something called the American Hydraulic Stone Company. So we researched the American Hydraulic Stone Company and found that they had a patented system for creating two-part concrete cast stone blocks. And so you see how the blocks don't even touch each other in the middle of the wall. We found other resources. This is a book on concrete. It had a whole chapter on American Hydraulic Stone Company, so clearly it was a thing. We actually were able to climb up in the attic and prove without a doubt that we had American Hydraulic Stone Company walls because we have the physical evidence there inside the wall. We also then, when we talked to them, this is before I've even gone down, right? Other than the one picture on the right. We then said, you know what? This was a military building originally, so I'm sure the original documents are going to be at the National Archives, which is not in Key West, but 3 miles from my office in Suitland. So drove to Suitland, found the original drawings. So here's the original drawings. We found historic photographs. This proved what we suspected, which is that we have iron framework inside the walls, which are corroding and causing the cracking. So here now we've gone down with our team. We've exposed the corroding lattice columns, which are filled with concrete and failing in varying degrees. Came up with a treatment protocol, and areas where the lattices were completely destroyed, we welded on new galvanized steel plates to allow the column to actually still serve its original purpose. And then worked with our masonry team to we cast all new blocks for the columns and the pilasters because they fell apart when we took them off. And so I've been working our way around the building, restoring the damaged cast stone, and I think we just completed phase 6 and are planning for phase 7. Every time they come up with some money, that's what they do. And then there's about handful of slides. I'll run through them real fast just so you can see kind of the other range of things we do. These are more recent projects. This is the Eisenhower Executive Office Building. This is restoring a painted dome. So this involved plaster repair, paint analysis, removal of all the paint from the surface, and then using the paint analysis to recreate the original paint scheme by the building. And then more recently, we've been taking down sculptures. We took apart the Downing urn from the Hauptgarten at the Smithsonian and put it into storage. They're getting ready to do a big project there. We disassembled cases carefully and put them into storage. This is in the children's room in the front, where we determined that the ceiling was very fragile and not well attached. And so we developed a whole system of lightweight supports and scaffolding to basically hold the ceiling in position while they do other construction activities. And so we installed this whole framework to support the ceiling. And then we're doing a couple projects at the Oak Hill Cemetery. This is the Linthicum Mausoleum, which, as you can see on the left-hand image, this is actually a laser scan, but the left-hand image shows that the front of the building is about to topple over, and the roof, the giant 1,600-pound roof sheets are falling off. So they're carefully disassembled again down to stable masonry and are in the planning stages for reconstruction now. While we were doing that, a truck ran through their main gate and destroyed the ornamental iron gate. And so we've now salvaged all those pieces, brought them back to our metal shop, local metal shop here in Bladensburg, and are working with them to restore all the lost, missing pieces, and also restored all the masonry piers, so that we can put the gates back in when they're done. And then lastly, we were told that the Portrait Gallery fence, this is 1865 fencing, all cast stone, cast in one giant panel, had been pulled over by an overly enthusiastic hockey fan and his cousin, and shattered into, so about 60 feet of fence is completely damaged. One section completely destroyed, has to be recast. But in the course of that, did an evaluation of the remaining fence and said, you know what, this is all kind of sketchy. And so we're in the planning process of getting ready to restore and recreate the missing sections, the damaged sections, and then, but also reinforce the fence in the future. So that's the speed dating version of what we do. And there looks like there are 4 questions in the chat. So let's see what we got here.
I think just 3. So
okay.
I'll read them so people can hear them on the video.
Okay.
When you do a paint analysis, can the property owner use that information to get paint from Home Depot, or do they need to go to a specialty shop of some kind?
So for the most part, it depends on what we're doing. So for the Eisenhower Executive Office Building dome, that project, that would have been, that would have been a commercially available paint, but it would have been very specialized colors, and we would have done a lot of analysis of the finished paint and its sheen, and there's a lot of variables that go into how paint appears, including lighting, the color of your light bulbs. There's just a lot of variables that go into how color is perceived. So the short answer is yes, you can use paint from a store, but if I'm going to get one bite at the apple of restoring the image that I showed of the paint analysis, that was for an ornamental sheet metal facade in Georgetown. There, you need to be able to take all the old paint off. It's all about prep, right? So, but yes, bottom line is, as long as you use a high quality paint, Sherwin-Williams, Benjamin Moore, you'll be fine. If you use low bit, you will get what you pay for, basically. So now, if I'm painting like that ornamental iron fence, there I'm going to use a specialty paint that's designed for high performance, long-term application. I'm not going to use a standard commercial paint. So that's when we start going into $200 a gallon and $500 a gallon paints to make sure that it's going to give me the highest possible performance for the longest possible.
Okay. And Jennifer Sizemore, who asked the first question, also asked this one. For the Union Station project, do the lights work? If yes, did you use LEDs or another modern solution, or are they actually carbon arc?
No, the carbon arc was long gone when we got to the project. When you opened up the domes, what you found were 5 spiral compact fluorescent bulbs that you would get at Home Depot, on little stalks, and not at all waterproof. So they had all fried. We took that all apart. We put in an entirely new waterproof conduit and system, and then a new high performance LED bulb that's much larger and has much greater illumination. And yes, so it's a low volt. We've installed a low voltage system. Whenever possible, we'll go back with a modern low voltage system, mostly because the bulbs last 50,000 hours. So I'm not in the process of going up and opening doors and replacing bulbs every couple months. We can go 5 years or more before we have to change the bulb. So
Okay. And then Gail Rothrock said, such a great presentation, such knowledge. I would call this what is historic restoration. I can't talk, so I'm sorry. I would call this what is historic restoration, and think you'd agree that preservation includes developing the laws, policies, and implementing agencies and boards and commissions.
absolutely, absolutely. We pick up where those commissions hand off. Often, we'll do initial analysis, but there is a whole set of stuff that has to happen. Mostly, I'm working for clients that already have an obligation to follow preservation laws, either from internal policies or because they are federal, or it's just in their DNA, or was required by whatever grant that they've gotten. Absolutely, this is just my piece of historic preservation to present the whole universe of historic preservation. I call it the preservation food chain. That's a whole universe of different skill sets and people that go into what is historic preservation. This is my piece of what historic preservation is.
So Jennifer just said thank you very much. And I'd like to say thank you very much to Alfonso. I learned a lot. It's amazing what you all do, and I've known you for a while, as we were discussing before things started tonight. And thank you, John Peter, for moderating, excuse me. And so thank you, everybody, for joining us. Our next history chat will be Monday, July 27th at 7 p.m. on Zoom. So I hope you can join us for that. So I'm going to stop the recording and say good night.